Good afternoon, everyone. My name is Marcus Atencio, and today I will be talking about the history of tech in music and music production. But before we begin, let me tell you a little bit about myself. I've been studying music and music production for around 15 years. Along with playing and recording music, I have also leaned heavily into the tech aspect of music production. This includes modifying and building instruments of my own and exploring new paths to make music with the latest tech. So, for this presentation, I want to focus on the history behind the tech used to make the music we hear today. Essentially, I want to focus on how we get from this piece of hardware, a Roland Juno 106, which to this day is still considered an essential instrument in any studio, to this software emulation of the same synth, which continues to be one of the most downloaded virtual instruments. So, first, let's start with a major event in the history of music that really birthed contemporary music as we know it today. That event is the introduction of synthesizers into the music landscape. Now, today, when we think of synthesizers, we usually think of a keyboard, and attached to that is some kind of button to scroll through settings, or some kind of interface for the user. The synthesizers started out as these enormous machines, as seen in this photo. These early instruments took up the size of about a kitchen cabinet, and the learning curve on these was very, very steep. As we can see, it's a collection of panels with knobs and buttons. They were very non-musical, as there was no interface for a trained musician to play chords, scales, or notes. So how did they work? And how do we get sounds from them? Well, if we look at this photo, the instrument is comprised of individual panels, and each panel takes in a voltage, manipulates the voltage, and passes out the voltage to the next panel. We route this voltage either through wires on the face of the panels manually, or the routes are hardwired under the hood. The source of this signal that creates the sound is called the controlled voltage. The source usually came from a device called a sequencer. A sequencer generates those controlled voltage signals and sends them through to the beginning of our signal path. The sequencer runs in a set loop and repeats the pattern that we input. There are many different interfaces for this, but above is a simple example. This one has 2 rows of red lit buttons or unlit buttons. The user selects where the notes go, and the sequencer feeds this loop of messages into the instrument. Now, this is starting to become conceptually clear. We have a pattern of binary code going into a device with individual panels of functionality that can manipulate or pass this data along and produce something that is more recognizable. And although these machines were a great starting point for musicians' entry into technology, the instruments themselves had limitations. And these limitations would provide motive to many builders on where and how to advance. First, there was no memory on these machines. If you stumbled on a sound that you liked, you would have to take notes on how you would get back there. You would need to hard code these settings to get back to that sound every time. Second, there was no signal standardization. The controlled voltages that these machines required to make sound all differed. Each company would determine how much voltage seemed appropriate to use. So sequencers and other methods of playability and control were set to a single brand or instrument. And third, from a trained musician standpoint, these machines were not playable. There was no way to know how to play a specific note or scale. So the instruments were mostly used by either non-musicians or very experimental musicians for sound effects. Most notably, we hear a lot of these used in early sci-fi films. So let's jump into one of the most interesting topics of music tech, and that is the advent of MIDI. In the early 80s, computing really started to take shape as something more recognizable to us today, and the production of microprocessors boomed and fueled a digital age that we still live in. This computerized boom also deeply affected music and instruments, as builders started to look into this new technology and seeing the potential of having computerized functionality in an instrument. But most importantly, this ability to add computing functionality to an instrument birthed the idea of MIDI. So the idea of MIDI was created by Dave Smith, who was the head of his own electronic instrument company in the USA. He saw the need for a globalized information system that could be shared by all brands and companies and allow for better integration of instruments into a studio. Now, this was an especially radical idea at the time, as home computers were barely becoming something that the public had access to. But we have these engineers already talking about setting up a globally standardized information sharing technology to provide better integration to studios. Originally, most companies didn't take to this idea, but Roland, the famous Japanese instrument company, decided to partner with Dave Smith and integrate this system into their instruments. And the first test was performed in 1982. It was very basic and simple. These two instruments, as we can see in this slide, were connected with a MIDI cable, and notes were played on one keyboard and were produced from the audio machine of the other. They demonstrated that one instrument could control the other with this globalized data sharing. But what is MIDI and how does it work? So MIDI, which stands for Musical Instrument Digital Interface, is a digital system that allows instruments to pass data between each other. So essentially, it's a data sharing system. And how does it work? Well, we can see a diagram of a typical 5-pin MIDI connector and a standard MIDI setup in this photo. Today, we are able to connect these MIDI-enabled instruments to our computers to pass data back and forth. We simply need to set our MIDI path from the computer towards an interface that connects the signal to our instrument. This enables us to play our instruments from our computers, and this ends up granting us endless possibilities. So MIDI was really the huge leap that brought computerized tech into music production. It gave musicians the ability to read, write, and store data, and it also solved the issues that plagued older synths. It was originally in binary and sent only on-off signals, but it has grown since the first tests in 1983. It also set the standards for musicians everywhere on how one could integrate tech into their work. But most importantly, it is one of the earliest examples of a globally standardized data sharing process. And this in itself is an incredible feat in the history of music, but also tech and computing. So now that we have seen the earliest examples of how computers were integrated into instruments, we can now look at how the home computer became the center of studio production. And this happened with the invention of the DAW, which stands for Digital Audio Workstation. This is one of the first home computers that was made available. It was called a Commodore 64 and really became the perfect tool of musicians. On its debut in the 80s, the computer cost around 600 US dollars, or the equivalent of 1,600 US dollars today. If we look closely on the side, there is a 5-pin MIDI connection port. This computer had the hardware potential to be integrated into a standard MIDI connected studio right out of the box. But what about the software? With this potential of data flow between the two technologies, the door really opened for software engineers to start building applications to talk to hardware instruments of the time. The start of this would be through digital sequencers. In this picture, we can see an image of the first digital sequencer, and it's a very basic program, 16 on-off binary switches and a tempo selector. This is one of the first instances of how we went from hardware to software. Sequencers from this point on would dominantly be in the form of software, and hardware sequencers would slowly start to disappear from studios. Now we have software that is able to control our instrument and pass data between our systems. And developers would keep building upon this computerized, or as it's referred to, in the box functionality. Then in 1998, two DAWs were released that offered audio recording, editing, and MIDI capabilities. This is when software finally took over studios. No longer did studios need to rely on expensive tape recorders for audio. This audio capturing could be done in the box. The audio could also be edited and adjusted with new functionality, like cut, copy, and paste. Pro Tools itself would become the industry standard for music production. Almost all music that you hear today has been recorded with Pro Tools, albeit a bit more developed version. And Cubase would continue to make advances in the fields of software. For example, in 1999, Cubase introduced this piece of software into their system. It was called Neon, and it was a virtual instrument that could be played by the user connecting a MIDI-capable keyboard into the computer, much like the setup that we saw before. Neon has stuck around and had many updates over the years and is still in use today. From there, the idea of virtual instruments spread quickly, and many studios ended up abandoning a lot of hardware instruments and effects for the software versions. Today, we have compact setups like this: a smartphone with a music app and a portable MIDI controller. This setup itself is capable of studio quality recordings with the right talent. And the simplicity and portability of this has been pretty revolutionary in music today. iPhones themselves offer access to GarageBand, which is an incredible DAW that gives its user access to hundreds of virtual instruments and sequencers. And with the ability to record audio as well, entire albums have been written using only GarageBand. The software itself has really opened up music production and set the entry level to music production a lot lower than it was before, seeing as access to these professional tools is open to close to anyone with an internet connection. In the past few years, there have even been several artists who have won Grammys with music that has been produced in their bedrooms using software. Now we have instrument companies putting out applications for mobile devices that can accurately emulate their old, hard to use vintage pieces of hardware. This being my personal favorite and one that I use often, it's called the Korg MS-20. What makes this emulation so interesting is that it brings the patching of a controlled voltage signal to software. The complexity of this system alone is really very impressive, and this is considered one of the best virtual instruments to emulate these older machines. Now that we are at a point where music production software is available to most anyone who wants to seek it out, how will this affect the future of music production? And where will the tech of today allow us to go with music and composition? One concept that has been introduced due to the current tech ability is generative music. This is a concept pioneered by a musician named Brian Eno, who most of us have already heard. He composed a lot of the Microsoft sounds as second long compositions, including the famous boot up sound that most of us remember from Windows. He also invented the concept of ambient music in the 70s, as well as produced an impressive amount of pop hits. But his generative music is the idea of never ending compositions that a user can also interact with. Bloom is an app made by Brian Eno that offers the ability to create generative music. It uses recursion to traverse an endless amount of possibilities on where a composition can go based on the user's input. So, along with decisions based on the user's input, Bloom also takes into account external factors such as time of day, date, and weather. So here is an official demo of this app released by Brian Eno. It's quite interesting to hear the sounds created along with the UI. As you can see, this app is really pushing the boundaries of what an instrument and composition can be in our world of tech. Along with compositional apps such as Bloom, there's been a huge amount of independent apps that have been released that have a huge range of functionality, from composition to sequencing to adding functionality to older instruments. Patchbase is a great example of this. This app utilizes the iPad and provides functionality to older instruments through MIDI. This added functionality has been so beneficial that a lot of these older machines are getting a second life and finding their way back into studios. This is incredible in terms of preventing decades worth of electronic instruments from becoming waste, and also building upon the tech from a different time. On the developer side, there has been a huge amount of tools created to aid people in the DIY community to create their own music apps. Tone.js is an API which gives the developer the functionality to build their own instrument. Tone.js has a huge following, and there are a large amount of resources on the web to start building your own instruments. The community is very active and encouraging. So, in conclusion, producers and musicians alike are starting to realize the potential of software and code within the field, whether it be creating truly unique pieces of music through the concepts of generative music or using existing tech to create their own virtual instruments. More importantly, the software being developed itself is starting to get recognition for its creativity and advancement of music. It seems that learning how to code may soon end up being as beneficial as knowing how to read music when it comes to production and composition. Here's a list of sources from my research. These sources range from the history of MIDI and DAWs to resources on the newest developments about generative music. Thank you very much for listening today. If you have any questions or would like to reach out to me, send a message through email or LinkedIn. You can also check out my GitHub from the QR code above. Thank you.